Hi, today we are going to solve another question about the circle, and the subtopic is angle subtended by an arc. Now in this question a circle is being given and all of the angles are already mentioned in this figure. What we have to find is angle X. Now to solve this question I mark this angle X with blue color. Similarly, I mark the arc AB with this orange color. Now you can see that this arc is subtending an angle 120 degree at the center of the circle, whereas the same arc is subtending an angle X at the circumference of the circle. Now we have a rule that the angle subtended by an arc at the center of the circle is always double than the angle subtended at the circumference of the circle. It means that if the angle at the center is 120 degrees, then the angle at the circumference will be half of it. So to find X, we write like this: 120 degrees divided by 2. So X is 60 degrees. Therefore, the angle X is 60 degrees, and the reason is because the angle subtended by an arc of a circle at its center is twice the angle it subtends anywhere on the circle's circumference. Now coming to the part 2, here we have to find angle DAB. This is angle DAB that we need to find. 2y plus this angle theta. So first of all we find this angle theta in this way. OA is radius. OB is also a radius. It means that triangle OAB is an isosceles triangle. Therefore, the base angles are equal, as I told you in my previous video in a question about circle. So these two base angles are equal. We can easily find the angle theta by using the property of the triangle that the sum of all the interior angles in a triangle is 180. Therefore, theta plus 120 degrees, theta plus 120 degrees is equal to 180 degrees. So 2 theta will be equal to 180 degrees minus 20 degrees. 2 theta is equal to 60 degrees, and hence we get theta is equal to 60 degrees over 2. Finally we get theta is equal to 30 degrees. Now moving forward to the next step, since we have to find 2y plus theta, first of all we figure out that this angle is 240 degrees. And how we have calculated it? Because the angle around a point is always 360 degrees. So in order to find this angle, this external angle, we will use 360 degrees minus 120 degrees, and we get 240 degrees, as this reflects angle 240 degrees. Now in order to find y, we use this property that sum of all the angles in a quadrilateral is equal to 360 degrees. We are taking this quadrilateral ODB like this. So this is quadrilateral OBDA. Using the formula that sum of all the angles in a quadrilateral is 360 degrees, we have to sum up these angles: x degree, y degree, 240 degrees and 2y degrees. It should be equal to 360 degrees. Since we have already found the value of x in the first part, which is 60 degrees, so we put here 60 degrees, 2y and y sum up to 3y, 240 goes to the other side and is subtracted. Finally, we get y is equal to 20 degrees. Now, we can use the value of theta and y in order to find the angle DAB. Therefore, angle DAB is equal to 2y plus theta. So we get 2 times 20 degrees plus 30 degrees. We get 40 plus 30 degrees is equal to 70 degrees. Therefore, the angle DAB is 70 degrees. In the third part, we have to find the angle BCD. This is the angle BCD that we need to find. But in order to find this angle, you must know that what a cyclic quadrilateral is. A cyclic quadrilateral is a quadrilateral which has all of its 4 vertices lying on the circle. It is also sometimes called inscribed quadrilateral. Hence, ABCD is basically a cyclic quadrilateral. And there is a property of cyclic quadrilateral that the sum of opposite angles of a cyclic quadrilateral is 180. Since we need to find the angle BCD, so we also take along the angle DAB, which we have already found, and it is 70 degrees. Therefore, we can write that the sum of the opposite angles in the cyclic quadrilateral is equal to 180 degree. So we can write angle DAB plus angle BCD equals 180 degrees. Now, DAB is already found, which is 70 degrees, plus BCD, we need to find it. 70 goes on the other side and is subtracted. Hence, we get angle BCD is equal to 110 degrees. You were watching the solution of question number 10, paper summer 2017, mathematics code 2024. It was Maths with Ms. Sumbal.